Hello friends, in the improper integral of first kind, we have the limit, either infinity, upper limit, lower limit, or both the limits infinity. And if the function is, say, suppose say in this example, 1 over x square and integration from 1 to infinity, when we find the answer as 1, that means the graph under this curve in 1 to infinity, though we have the infinity, the area under the curve is finite. And here the graph of 1 over x square in 1 to infinity is like this, very, very near to this y-axis and very, very near to this x-axis. So this area from 1 to infinity, okay? So 1 may be here. So from 1 to infinity, this small area is nothing but 1. That is the meaning of this improper integral of first kind. So similarly, this example 1 over 1 plus x square, its graph in minus infinity to infinity looks like this. And in 0 to infinity, this is the graph for this area. And this area is finite, and that value of that area is pi by 2. So we have like minus infinity to 0 e to the power x. So the graph from minus infinity to 0 e to the power x is very, 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 very near to this x-axis. This is in minus infinity to 0. And that area is also finite. Same way, say like x e power minus x square minus infinity to infinity. So the graph of x e power minus x square in minus infinity to infinity looks like this. And here and here is like this. So here we say that minus infinity to 0 and 0 to infinity. This area negative, this area positive, but same area you can see. And then we get the answer as a 0. Now, improper integral of second kind. So here in improper integral of second kind, what do we have? We have like this. We have the situation here. Just let us give one example. Like we have integration 0 to 1, say 1 upon x. So at this lower limit, the function tends to infinity, or you can say unbounded. It may happen that like at 1, this function tends to infinity. It may happen that like we have 0 to 2. So that one lying in the interval 0 to 2. And at that point, this function tends to infinity. So in such a situation where the limits finite, limits of integration finite, but the function gets infinite. So such a integration is known as improper integral of second kind. And if we come across improper integral of second kind, then how to evaluate? So suppose we have integration say a to b fx dx, and fx tends to infinite as x tends to a. Then we can evaluate this limit like this. Integration a to b fx dx equal to limit c tends to a integration from c to b fx dx. Same way, if we have integration a to b fx dx and this fx tends to infinite as x tends to b, Then integration a to b fx dx is equal to limit c tends to b integration from a to c fx dx. It may also happen that integration means integrand fx tends to infinity, integration from a to b fx dx, where fx tends to infinity if some c lying in the interval a to b. So in that case, we have to do like this: integration a to c fx dx plus c to b fx dx, and here limit c tends to c1 a to c1 fx dx plus limit c2 tends to c integration from c2 to b fx dx. That is the way we can evaluate the integration. So let us take one example. Integration from 0 to 3, 1 upon root 3 minus x dx. So this is an improper integral of second kind because this 1 upon root 3 minus x tends to infinity as x tends to 3. So integration 0 to 3, 1 upon root 3 minus x dx is equal to limit c tends to 3, 0 to c, 3 minus x power minus half dx. And this is equal to limit c tends to 3. Now integration of 3 minus x power minus half. So that is 3 minus x power minus half plus 1 minus half plus 1 and negative sign for the 3 minus x. So that is minus 1 and 0 to c. So this is total 1 by 2 and negative sign. So is equal to minus 2. Limit c tends to 3. This is 3 minus x power 1 by 2. So this is 3 minus c power 1 by 2 minus 3 power 1 by 2 x0. Now c tends to 3. So this is 0. So this is minus 2 into minus 3 power 1 by 2. So that is root 3. And so this is equal to 2 root 3. It is convergent. Let us take next. Integration 0 to 5 1 over x square dx. Now this 1 over x square tends to infinity as x tends to 0. So this is improper integral of second kind. So 0 to 5 1 over x square dx equal limit c tends to 0 c to 5 x power minus 2 dx. This is equal to limit c tends to 0. Integration is minus 1 over x c to 5. So this is limit c tends to 0 minus 1 by 5 minus minus plus 1 upon c. But then as c tends to 0, 1 upon c tends to infinity. So this tends to infinity. And so this integration is not possible. And so we say that it is divergent. Okay, take one more example. Integration 0 to 3 dx over root 9 minus x square. And this 1 over root 9 minus x square, this tends to infinity as x tends to 3. So this is 0 to 3 dx over root 9 minus x square equal to limit c tends to 3, 0 to c dx over root 9 minus x square equal to limit c tends to 3. This is nothing but sine inverse x by 3. This is standard formula, and that is 0 to c. So this is limit c tends to 3, sine inverse c by 3 minus sine inverse 0. Sine inverse 0 is 0. And when c tends to 3, this is nothing but sine inverse 1, and so that is pi by 2. So that is finite, and so you can say that this is convergent.